Hi guys, Buildzoid here, and today we are going to be taking a look at the RX 6800 XT Red Devil PCB from Powercolor. Now, before we get into this, the PCB pictures are from Tech Power Up's review of the card, so big thank you to them for providing high-res PCB pictures in their reviews. Also, if you care about things like noise, thermals, power consumption, performance, you should go check out their review of the card, because that's what their review focuses on. But they also do have, high-res PCB pictures, which makes it possible for me to make these videos. Anyway, let's get into it. So, in typical modern GPU fashion, we have two rows of power delivery on either side of the GPU core. Over here, we've got 5 phases of V-core, and then two phases of SoC power. So we got that down there. Then on the other side, we've got 2 phases of memory power up top. So that's our memory power. Then we've got 1 phase of VDDCI, also known as memory controller power. And then we've got 9 phases of vCore again. So you've got a 14-phase vCore VRM, 2-phase SoC VRM, 2-phase memory VRM, and a 1-phase VDDCI. The controllers for all of these voltages are on the back of the card over here. We've got a IR35217, and I should actually label them. Unfortunately, I can talk faster than I can write. And I am using a drawing tablet. I'm just really slow. And then the XDPE... What the hell is that? Man. Anyway, 132G5C. So the 35217 handles the VSOC and... I remember? Yes. Yeah. VSOC and VMEM rails, and the XDPE132G5, or at least it should be handling those two rails. Like, the thing is, it could be either controller doing it, because the XDPE132G5C is a 16-phase controller, so you still have the option to hook up either of the 2-phase rails to the 132G5C, but anyway, this thing is definitely controlling vCore and probably VDDCI. So the vCore is a real 14-phase because the XDPE132G5C is like the highest end voltage controller currently made by Infineon, goes all the way up to 16 phases, fully digital, got basically all of the features that you could possibly get from a controller from Infineon right now. Yeah, so this is about as high-end as a VRM controller gets. And then the 35217 is, that's actually an 8-phase controller. This was the controller originally introduced with the Vega cards. Also, fully digital, very high-end voltage controller. Like, the XDP basically just adds more phases to the functionality of what you... And actually, no, I think there's like a voltage monitor... Like, this might have more accurate voltage monitoring functionality. Like, I think this actually supports, like, 1 millivolts voltage settings. I don't think AMD actually uses that, but I kind of remember seeing that either in, like, the product brief or something like that. Should have probably included that in the notes. Either way, the thing is, on GPUs, you don't actually see... Like, the thing is, this controller, in every configuration I've seen it in so far, has not used, like, a lot of the advanced features other than the crazy phase count. Anyway, the 35217... A-phase controller, also fully digital, very high-end. Like, honestly, kind of overkill for the SoC and memory rails. And I'm really surprised that, well, actually, I'm not sure. It might actually be required, but if you look at 5700 XTs, for example, the reference 5700 XT uses a pair of IR35217s for all of its voltage regulation, and then all of the aftermarket cards replace the second 35217 with an NCP81022 because the 35217 is really, really freaking expensive for, running a 2-phase memory VRM and a single-phase VDDCI. And even here, an NCP81022 would have more than enough phases to support both the SoC and the memory rail. So I'm kind of surprised that, the 35217 is used. Like, all of the aftermarket cards I've seen, they keep using the 35217. So I'm guessing that maybe AMD just requires the 35217 now for the SoC and the memory rails. But I'm not I'm not 100% certain on that, but still, it's like, there's nothing to complain about for having a better voltage controller, right? So, yeah. Anyway, so that's the controllers that the card uses. And for the power stages, we are looking at a whole lot of TDA, like all of the VR, like all the main power rails use the same power stages here, and those power stages are TDA 21472s. These are 70 amp smart power stages from Infineon / International Rectifier. It's kind of funny, the TDA 21490 has an Infineon logo, the 72 has an IR logo. You can just about make out the I over there and then the R. So anyway, yeah. Like, it doesn't really make a difference. Infineon owns International Rectifier, so these are pretty much Infineon parts. Actually, this is like an Infineon part number with... Because if this was an IR part number, it would be like IR whatever, or IRF whatever, but TDA was like... The TDA part numbers were used by Infineon before they acquired International Rectifier, so it's kind of interesting that like they changed the part, like the part number is Infineon, but then the label, like the logo on the package is anyway, doesn't matter, it doesn't affect anything. So smart power stages are called smart power stages because they have a bunch of extra functionality built into them that you wouldn't like necessarily have in other power stages. So you have very accurate current monitoring, at least in the higher load ranges. At very low output currents, the accuracy is actually kind of garbage. They tend to over-report output power. But once you put a significant amount of current through them, they are very, very accurate. And with an XDPE132G5C, like you can get very, very accurate GPU power. Like any rail using the smart power stages, you can get very accurate power readings for those. Also with the 35217, it's just a matter of like, are the controllers properly accessible to software? Anyway, so accurate current monitoring, built-in temperature monitoring, and then a bunch of safety features like overcurrent protection, over temperature protection, short circuit protection, and then even more safety features past that I just didn't really find that interesting, so didn't bother including them in my notes. So yeah, smart power stages are actually really smart because there's just a whole bunch of extra functionality built into them that you would otherwise have to implement with external circuitry. And the other cool thing about these is these being 70 amp smart power stages they're also ridiculously efficient. So the 14 phase V-core VRM on here is capable of outputting is capable of pushing a lot of current into the GPU core without producing a ton of heat. So for 400 kilohertz switching frequency, which like that's just what the documentation uses for all of its performance curves. As far as I know, the actual cards run 500 kilohertz switching frequency, which shouldn't really make too much of a difference. Like a lot of the modern power stages have pretty similar efficiency from like 400 to like 600 kilohertz. And then once you go past 600, the efficiency starts really dropping off a cliff. But before that, it doesn't make too much of a difference. Anyway, so 400 kilohertz switching frequency, assuming an output voltage of 1.2 volts, which is a bit high for... Like, as far as I know, these cards don't run stock at 1.2 volts. They run less than that. So this is also a bit high, but unfortunately the documentation is like it's spec'd at 1.2 volts or it's spec'd at 1.8. So we're going to go with like this is closer to the actual real world scenario. So 200 amps output, the VRM will produce only about 16 watts of heat. And this right here is actually outside the efficiency curve, like outside the peak of the efficiency curve, because this being a 14 phase, this hits peak efficiency at around 280 amps output, because the 70 amp smart power stages hit peak efficiency around 20 amps output. So 200 amps is a little bit too low for this many phases. But depending on how Powercolor has which actually they're not going to have phase shedding. Like the thing is, if you had the optimal number of phases, instead of making 16 watts of heat, you'd be making like 15, which this isn't a laptop. It's a 300 watt GPU. Nobody cares. Like 1 watt of VRM power loss is just completely irrelevant on a 300 watt, product. So unless you're NVIDIA, in which case, like if you, and you're about, well, no, I'd still consider it basically irrelevant. With NVIDIA's power monitoring systems, you can actually end up in awkward situations like the fans stealing GPU core power, because, that's a reasonable way of doing power management, isn't it? Anyway, 300 amps output, the VRM will be outputting about 24 watts of heat, so now it's actually, pretty close to the peak of the efficiency curve. The thing is, at 24 watts of heat output, you do actually need some kind of airflow or heat sinks. The thing is GPUs come with their own VRM heat sinks, and they have fans blasting down directly on them. So there's not really, this isn't like a motherboard where there's a scenario where the card wouldn't be getting any airflow, right? So it makes it kind of like, so 24 watts of heat output on, say, a motherboard VRM, kind of high. On a GPU, not really. Um, Anyway, moving on, 400 amps output. So like, this is just fine for a GPU VRM to produce as heat, especially because like with the split VRM, you get the benefit of like not having all the heat concentrated in one big row of power stages. Though you'll still probably see a hotspot somewhere in this area and probably right there, for the VRM. Actually, might be leaning towards this phase, but it depends how much power the SoC VRM has to output, but I don't actually have like figures for how much current each rail has to provide. Anyway, 400 amps output, the VRM will produce about 35 watts of heat, and 500 amps output, the VRM will produce about 47 watts of heat. So currently, this is actually the most powerful VRM you can get on an RX 6800 XT. So good job, Powercolor. The funny thing is, they actually just sort of like, this actually is basically the reference VRM, but plus plus 4 phases, because the reference 6800 XT is a 10-phase V-core. Powercolor has basically taken the reference PCB, stretched it a bit to accommodate the extra phases, and honestly, that's great, because like, reference AMD PCBs are generally really, really solid, and most of the time what I expect to see from the various aftermarket cards is for them to find, like, trying to find ways to make the card cheaper, not taking the reference design and then making it even more expensive. So yeah, this right here, I'm a fan of the power delivery. It's just a real shame that there's kind of like, the thing is, like, this VRM is more than capable for even like LN2 overclocking. But if you've seen Der Bauer's recent video about overclocking the 6800 XT, well, AMD has, decided that it would be really funny if they restricted the 6800 XT's max clock speed to 2800 megahertz. And I like, the thing is, there's a chance. So I think there's a chance that you could take a 6900 XT BIOS, which that BIOS is limited all the way to like 3000 megahertz, and you could slap that on a 6800 XT, which with a card like this is relatively risk-free because you do have the dual BIOS from Powercolor. So thank you, Powercolor, for that. Because I think, like, the issue is modern AMD GPUs check driver signatures. So if you modify the check BIOS signatures. So if you modify the BIOS, you can't post. Like, the GPU won't even turn on. It's not a case of like, you'll turn on, get into Windows, and then the drivers will go like, oh, your GPU isn't real. Well, how dare you try to do whatever? No, like, modern AMD GPUs, you change one bit in the BIOS, and it's like, nope, not posting anymore. So you can't like take the 6800 XT BIOS and like unlock the limits, not without AMD's permission. And well, why would AMD give you permission, right? Like, who cares about having world records? So instead, what you could do is you could take a 6900 XT BIOS, because AMD GPUs have historically been absolutely terrible at actually distinguishing themselves from each other, which is why you can do like, why you can take like a 5700 XT BIOS, slap it onto a 5700. Now you have 5700 XT power limits and frequency limits and voltage, and you could basically push limits around by doing that. Similar with the Vega 56 and running a Vega 64 BIOS. Or back in the day, you could actually unlock cores on certain cards like HD 6950s. You could unlock cores by slapping 6970 BIOSes on those. On Furies, you could take a Fury X BIOS and get a Fury X out of your Fury if you were lucky enough to have a chip with all the cores unlocked. You could also run custom BIOSes on the Furies, which you can't do anymore. So the thing is, you might be able to bypass the 2800 megahertz clock limit with a 6900 XT BIOS. However, I still think 3 gigahertz is going to ultimately be too low. Generally speaking, like, if you take a GPU on LN2, you should be able to go Like, in my opinion, AMD should have set the frequency limit to like 2 times the stock clock speed. That would have been like a reasonable limit, because we've had GPUs for a while now that were doing close to 3 gigahertz, if not like close to, if not more than 3 gigahertz. Just look at I think GTX 1060s and maybe the GT 1030 were like the first cards to hit 3 gigahertz. You had a lot of, 10 series cards running, around the sort of 2.7 gigahertz range up to, I think there was 1080 Ti's doing 2.8 gigahertz for some benchmarks. And those are cards that come with like a stock clock of like 2 gigahertz. 6800 XTs come with a stock clock of around, 2200 to 2400, like 2400 megahertz. And it's just like, so why does the 6900, like, why is the frequency limit so low? Does AMD hate overclocking? Probably. Or actually, no, I don't think they hate overclocking. They just don't actually care. So they arbitrarily set the limits too low, and now it's like, oh, well, who cares? Like, the thing is, for the vast majority of AMD's customer base, it doesn't affect them because, like most people forget and don't even enable XMP. But yeah, it really kind of is like, what's the point of a card like this right here if you're just going to ultimately just slam right into AMD's arbitrary software limits? Right? Like, really, what's the point? Because the thing is, if you water cool the card, if you get voltage control, and you can get voltage control, it's super easy with the controllers that you have here. You could potentially plug in a Infineon USB 005. You can use an Elmore Labs EVC. You can get direct voltage control. If the card has any scaling at all on sub-zero temperatures, you should be able to just slam right into that 3 gigahertz limit. And where's the fun in that, right? So, yeah, that, as far as I'm concerned, is super disappointing. But considering we are talking about the company that considers the Fury X an overclocker's dream, how am I not surprised? The funny thing is, like, the old cards had actually like 7970s and all of those old cards, like, you had, like, I'm pretty sure you can set up to like 2 gigahertz core clock on a 7970. It won't actually run, but there's no restriction in the software preventing you from trying to run a 7970 at well over twice its stock speed. And then there's the 6000 series where it's just like, oh, like, you should be able to max out the slider on water cooling. Like, which is dumb. Like, the slider should not, like, that's just dumb as far as I'm concerned, which really, like, makes it a waste for Powercolor to have a VRM like this. Maybe we'll see a 6900 XT, like some custom 6900 XT with a proper frequency limit, and then we can just take that BIOS and slap it onto this card, or any of the other 6800 XTs, but yeah, they're like, I don't know why AMD does this to themselves. I really don't. It's just like, it would be so easy to just like not screw up. Like, why? Why have a silly software limit like that? And somebody's going to be like, it's to not step on the sales of the 6900 XT, but even the 6900 XT has a stupid limit. Right? Like, 3 gigahertz is not enough on a GPU that comes stock at over 2 gigahertz. In fact, like, so yeah, it's just, I have no idea why AMD has such low frequency limits. And it really, like, it's just disappointing to have that on a card like this. Because it's like, so we've got this really great power delivery, but you're not going anywhere with it because you're going to run out of headroom on water cooling probably. So yeah, good job, AMD. Good job. I mean, it wouldn't be an AMD GPU launch if something wasn't broken. Like, apparently the drivers aren't too bad. So instead we just broke the overclocking. Isn't that great? Anyway, so yeah, the vCore VRM here is crazy powerful. Unfortunately, you're just never going to be able to take advantage of it because of AMD's silly software limits. For the SoC VRM, we have, more of the same with the 70 amp smart power stages. So I'm going to assume that there's, plenty of headroom on that. Again, I don't know how much current this is supposed to be able to output, but it's the same SoC VRM configuration as you see on the reference card, and AMD's reference cards tend to be pretty overkill in the VRM department. So yeah, this should be just fine. And same goes for the memory power and the VDDCI rail. Actually, I think this must be the biggest VDDCI rail since the 290X. Yeah. Yeah, this is actually no, the 5700 XT also had 70 amp power stages everywhere. But I think the 70 amp power stages everywhere on the 5700 XT was like minimizing the variety of parts being used in production. And whereas this is a non-reference card. So if Powercolor wanted to do cost optimizing, I'm surprised that they didn't cut down the VDDCI. So this should be massively overkill as well. Also, the TDA21472 is actually a slightly better 70 amp smart power stage than the FDMF3170s that you would find on a 5700 XT reference card. So yeah, this should be more than enough memory controller power as well. For the output, like the thing is, okay, like the thing is, there's not much point in me praising the fact that we've got like all SMD aluminum polymer capacitors. Though admittedly, Powercolor does seem to be shaving off some cost with the capacitors here, because the reference card and a bunch of the other custom cards seem to be using Panasonics, whereas these are definitely APAC. And APAC is like the cheaper alternative to Panasonic for your SMD aluminum polymer capacitors. These, which it's not a terrible thing, because in terms of ESL, these are still way ahead of your regular through-hole capacitors, or any kind of CAN capacitor. Like this package style just has a massive ESL advantage. But in terms of ESR, these can be inferior to the Panasonic capacitors, depending on which exact like part number of Panasonic SP cap AMD is using on the reference card. So these seem to be a slight cost optimization, but they're still polymers, and the main benefit that you get, like they're still SMD polymers, and the main benefit you get with these is the lower ESL. The ESR is kind of like it's not as important as the ESL advantage, because you can have actually relatively high ESR SMD polymers just absolutely wipe the floor with their through-hole counterparts that have less ESR. Because the ESL is actually what dominates in the high frequency when it comes to filtering out high frequency switching noise, like say GPU core transients. So yeah, like these are a bit of a cost optimization, but they're still perfectly fine because they're still SMD capacitors. It's not like the 5700 XTs where the reference card is a bunch of SMD caps and then the aftermarket cards replace the expensive SMD polymers with a bunch of through holes, which I still don't think necessarily made that much of a difference. Generally, like the thing is, different capacitor configurations, you're looking at tens of millivolts in terms of voltage regulation difference. So tens of megahertz in terms of overclocking range adjustments. And again, there's a limit on the freaking frequency slider, so it's like, who cares about the output filtering? As soon as you hit the 2800 megahertz limit, you're done. And then past that, the capacitors just don't matter anymore. So, yeah. Anyway, that's the sort of the bulk capacitors on this card, and Powercolor's using the APACs absolutely everywhere. Right, so VCore. Though interestingly enough, there's like a Panasonic here and a Panasonic there, which is really random. Maybe there was a supply thing. Like maybe they just ran out of Panasonics and they had to switch to APAC capacitors for this one. They might actually use them interchangeably, which wouldn't necessarily surprise me. But anyway, actually no, because this is on a different power rail. What's this on then? I'm not sure. Anyway, that's downsides of working from a photo. Yeah, so that's the bulk capacitors, which I'm a big fan of SMD polymers, even if they're from APAC. Because even if they're from APAC, the ESL advantage is still very real and still kind of significant for power filtering on GPUs and even motherboards actually. Anyway, then behind the core we have this right here, which I think I counted this. There seems to be well over 200 multi-layer ceramics sitting behind the core. If I had to guess at the size, these are 0402s. They look a little bit too small for 0603s. But they're definitely, that's an 0201. That's an 0201, so this is probably an 0402. Anyway, yeah, but there's like over 200 of them. And this is not really new for AMD GPUs as far as I'm concerned. Like, if you look at the 5700 XT, you basically have a smaller version of this, which makes sense because the 5700 XT pulls less power than the 6800 XT. So the card that pulls more power obviously also needs more filtering. Also, this runs at higher frequencies, which potentially, which makes it even more difficult to do, which makes the transient, like the switching noise that the GPU core produces, potentially even higher frequency. So again, you just need, ultra low ESR, ultra low ESL filtering for the core, and multi-layer ceramics in very, very large quantities are sort of the optimal way of achieving that. So that's what's going on with that. But the thing is, this is pretty normal for AMD cards. I mean, no, it's pretty normal. Like, look at Vega. Admittedly, Vega is like a bunch of 0805s, but the focus on having just piles of multi-layer ceramics directly behind GPU cores has definitely been a thing for AMD GPUs for a very, very long time now. Whereas putting, basically bulk capacitors behind the core is more like an NVIDIA thing, going back ages and ages and ages. So yeah, so that's the output filtering. And again, unfortunately, once you hit the 2800 megahertz limit, it just doesn't matter what you have. And the other thing is just so yeah, I'm actually really salty about the limit. I'm really annoyed with that. That is so incredibly stupid. Actually, it's so stupid that I might not buy a 6900 XT now that I think of it. Unless we find a way to bypass that 3 gigahertz wall, what's the point? I'm going to go give NVIDIA my money, because NVIDIA might have more stupid, NVIDIA might have, more restrictive power limits and stuff, but they're easier to bypass than AMD's. Because, unfortunately, AMD's super smart digital voltage controllers also mean it's really difficult to, disable certain, power monitoring on an AMD GPU. Very difficult to bypass. Very, very difficult to bypass. On an NVIDIA card, much easier. So, yeah. So good job, Powercolor, for designing a great card. Shame on AMD for ruining the overclocking experience again. Seriously, the best card AMD made was the 290X, and they've not managed to repeat that success since. So, is there anything else I wanted to talk about with this card? Not really. Yeah. Just, there's no point. You're gonna max these out on ambient. So, yeah, that's it for the video. Thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link in the description to that, and that helps out immensely with running the channel. Especially now that I'm considering maybe getting a 3090 instead of the 6900 XT, it would be much appreciated if you would check out the Patreon. And then there's also the, what else? The AHOC Teespring store, where you can pick up shirts, stickers, posters, the usual YouTuber merch. Same deal as the Patreon. I'm very strongly considering a 3090 if AMD doesn't remove the clock walls. Because, I've had enough of this with AMD just pointlessly ruining the overclocking experience on their modern GPUs. We've not had the best best overclocking card from AMD in recent history is the RX 580 and the 590. Because those are the least modern ones. They had this old boost algorithm that didn't really do wasn't really boost. It was just kind of was pretend boost. And they didn't have any stupid limits. You could still flash custom BIOSes to them. Everything was great because they're older designs without all the new restrictions that we now have. So, yeah. The best argument for buying an NVIDIA card is AMD. It's what AMD does to their own stuff. Anyway, well, good job Powercolor on the PCB though. But yeah. So that's it for the video. Thanks for watching, and goodbye.